Good morning, one and all. Today we'll discuss the effects of undersampling. That's effects of undersampling. Generally, the sampling will be done in the three cases, like oversampling, undersampling, and critically sampling. In the undersampling case, we know that the y of spectrum, the spectrums whatever we have will be overlapped like this. This happens because of the first spectrums will be from 0 to omega m and here minus omega m. For n is equal to 1 spectrum, it will be omega s minus omega m. This has omega s plus omega m. And this has is 2 omega s minus omega m. This has 2 omega s plus omega m. In the negative side, this has minus omega s minus omega m. This has minus omega s minus omega m. This has plus omega s. We'll observe this and omega s minus omega m will be very less than omega m. Therefore, omega s will be less than 2 omega m. Hence, the Fs will be less than 2 Fm. Fs will be less than 2 Fm. Therefore, when this FSP will be less than 2 Fm, it is the case of the undersampling. It is the case of undersampling where the spectrums will be overlapped. This overlapped, because of this overlapping, the spectrums occurs the distortion. Because of this particular overlapping, the spectra occurs the distortion. The distortion is called as aliasing. Now, to avoid this particular aliasing, or to causes this particular aliasing, we know the cause. To know the causes of this aliasing, first one as to causes of aliasing, that is Fs will be very small, Next, x of omega is not band limited, and to avoid the aliasing, first thing is, if the Fs is very small, aliasing will occur. Therefore, to avoid the aliasing, Fs should be greater than or equal to 2 Fm. That's very large values. Fs should be very large. And similarly, the second point is x of omega is not band limited. Therefore, to make this x of omega band limited, x of omega is band limited. How it will be band limited is, before the sampling, this x of t will be given to the low pass filter or anti-aliasing filter. Then take the process of sampling. Then we do not get the output is not aliased. Output is not aliased. Those are the two reasons of aliasing is Fs will be very lesser value and x of omega is not band limited. Therefore, to avoid the aliasing, fs should be greater than or equal to 2fm, and x of omega is to be the band limited. To get that x of omega as band limited, before the sampling, perform the low pass processing or the anti-aliasing filter, which removes this aliasing process when we perform the sampling process. Okay, that is called as the effects of undersampling.